Hello, everybody. My name is Alessandro Pireno, Sandro for short, if you talk to me, give me some milliseconds. And I'm here to talk about the impact of using knowledge graphs when building RAGs, basically, so retrieval augmented generation. First thing is just a bit of getting to know you guys. I know everyone has the little icons, the hearts and the thumbs up. Can you give me a thumbs up or a heart if how many people of you are data scientists who know what RAG is? All right, there we go. So don't have to start there. Great. How many people are playing around with knowledge graphs right now? Maybe do the little explosion guy, the little horn thing. Oh, not many. Oh, a few. All right, great. Awesome. Whoa, and we got the explosion. There we go. A little bit of background about me and where I'm coming from. I've done a lot of different things in my life, but from this context, I'm a data nerd and I'm working for a database company. So we're here to kind of make the art of the possible happen on the data side. So let's just move into content here. Okay. So the first thing is, let's just talk a little bit about knowledge graphs. I saw a mix of reactions about people who are talking about knowledge graphs. In general, it's just a different way to organize your data. So in this case, it could be pulling 10K forms or a novella, which I'll be talking about in this particular example. It could be logs, anything. Anything that generates data can also be represented as a graph. And it could be an org chart, or it could be something pretty. It could be a workflow diagram for an application. Generally speaking, that's what a knowledge graph is. So hopefully we get the gist there. Now, knowledge graphs. Generally speaking, a lot of people talk about nodes and edges. So a node is anything that is an entity in your corpus of knowledge. It could be people, places, computers, destinations. It doesn't really matter. An edge is basically the relationships between any of those nodes. So in a simplistic universe, we could talk about someone like Marie Curie. She is, or technically was, a scientist, which is another thing to consider as well. And she won a Nobel Prize, right? So you have tenses, you have things like that. But even within the edge, you have the capability of understanding more than just properties of the nodes. So the year that she won the Nobel Prize, which I don't know off the top of my head, which would have been great to have a knowledge graph in front of me with that, for instance, right? And when I think about the power of the graph structure, it's like a map for navigating your data. It creates the roads. It allows you to answer complex questions. Look for the hidden patterns between things. Sometimes just having a graph and seeing somebody is well interconnected to lots of people is really important. The fact that you can gain insights that are more difficult to achieve than other approaches. So it's a concept if you're doing a relational database and you had to do multiple nested joins to each other, and that's complicated. This makes it simple. So you can start thinking about things like, recommendation engine terms. People who bought this also bought this. What is the shortest path between two people? It's not Kevin Bacon, but yes, the between people to connect things. So it allows you to start answering questions that are very difficult to answer if you just had an Excel spreadsheet, basically. And the nice thing about this, it allows you to have more tools in the tool shed, but it lets you go after more expressive ways to store your data as well. So as I mentioned, the edges themselves are important, not just because they're lines connecting two people, but how you met, the description, the fact that, you might be the progeny of a mother and a father, and it's more than just their genetics or your the fact that one's male, one's female. That's all about them. It's really the relationships between you. So you might like to go with long walks with your father, and you might like to, I don't know, drink whiskey with your mom. Those are things that are not to do with just you and them. It's about the connections, because they might not want to do that with each other either. So that's a family dynamic. I'll leave that to you guys. Now, by the way, I will suggest again, if you have any questions, please pepper them in here, and I'll be mindful and then come on. This is an example of a knowledge graph I built on a little novella that was generated by AI. I'm going full whole hog here. The concept here is it was a little thing that was written. It's like a little sci-fi book type deal, and I'll get into how I generated this. But this is just graphically representing what the graph would look like. And if we can take a look at here, just basically you can see there's people and there's places and there's a connection strength. And there's a little bit more metadata when we get into it. That's the graph side. So talked about graph. I know everyone here just pretty much all said thumbs up on RAG. So I don't have to spend a lot of time here, but I just want to reiterate an embedding, which empowers RAG, is really about the retrieval part, and it's just about numerically storing semantic information about your corpus so you can effectively retrieve it. And again, just to reiterate, it's a way to take your data, be it images, anything, understand the context of that data as it relates to other data, store it that way, depending upon your model. And we're not to go into, I'm sure you guys had lectures all day long on different models and things like that. But I also just like to highlight, though, it's more than just semantic search and RAG. It also is really useful in recommendation systems. Conceptually, you don't have to just say like, hey, what did this person buy and other things that other people bought. You can also connect them via reviews, content of reviews to content of reviews. Really interesting ways that you can explore that. And it also allows you to find hidden connections, especially when, even something as simple as like a fuzzy full text search isn't really good enough. You can start finding different connections and, make these kind of virtual joins between climate change and, in this example, renewable energy. I find all these things fascinating, but in this context, we're going to talk about how these empower RAG to another level. So what does this mean for RAG? So this is where it's really interesting. So we all know how a normal RAG works, right? You have a question, you have your vectors, you do a vector search, and you say, based on some input, let me find this question, what thing's relevant to this question, and then you put it into a context window, and you submit it to your LLM. You say, answer this question. And by the way, here's all the information that might be relevant, depending on how you build your prompt, then come back with an answer. Now, this is great. But when you also employ a knowledge graph as another source, it becomes really interesting for a few reasons. And one is you're going to give structure that the LLM would normally not have. So you're kind of giving it like a cheat code. And you can do this in multiple ways. And I'm not getting into prompt engineering here, but you could say, only use the corpus information, and here's a graph for informational purposes. You could say, use the graph as the definitive truth, and here's some background information, et cetera, et cetera. But the other nice thing about this is it allows you to play with your context window in a lot more efficient ways. So if I were to give the entire encyclopedia to an LLM as being the context window, it's too much, right? So generally you're going to chunk it up and you're going to give the segments of the information within that corpus that are relevant to your question, which is the semantic search part. However, if you also layer in a graph, now you're going to be able to put in a lot more rich information about how concepts are connected to each other as well between the chunks. So getting into different approaches for that. But generally speaking, when you extend the semantic search of graphs, as I mentioned, you can extend the context, right? You can also create the relationships between the entities within that corpus and give more information to the LLM. That's like a shortcut there. And it also allows the reasoning capabilities of the LLM to really shine. They can actually say that they're considering the graph here and they're not considering that. You can actually watch this happen. And generally that just improves your accuracy. It reduces hallucination. And, it means that you can also have more dynamic information that encyclopedia is not changing over time very much, right? But external things might be changing all the time. So your corpus can be also disconnected from your graph. So you might want to give it the full, maybe not the full, but like the employee and the employees and how they're related to the CEOs and et cetera, as part of the information to be considered. And suffice to say, GraphRag is here. And if you're not using it, you should really consider it because I've found it very illuminating. It's very fascinating to see this stuff work. So moving on. Here's an example of a prompt. Now, if you recall, this was based on that little novella. And here's an example. So you give the prompt, and then just basically you put it between some form of tags that would recognize, like, here's where your knowledge graph goes, and your question would be there. Very simple prompt. We're not going crazy on which APIs, et cetera, or being very LLM agnostic as well. This would just generally work in different contexts. And just to give you a simple example, again, this is very, very simple. They can get much more complicated. In this particular example, we have people in place and how they're related to. Now, just in terms of this UX representation, this is just how we represent schemas visually. And you can see a few things here. You see these arrows and that little icon there that looks like two of them are tables, and that little thing that's two dots connected to each other represents an edge table, what we call a relational table, and a relate table. So basically, we see properties of description, embedding, and we can see that a person is always going to be related to either a person or a place. And the descriptions are basically what the embeddings are calculated on. And we have a strength, which is a factor which on how I generated this is dependent. But generally speaking, if this is your concept of what your graph looks like, call strength confidence. It doesn't really matter. You get an understanding of where you can go with this. I'll pause here. It's a very simple diagram, but it can generate some questions. None? Just checking. Okay, great. Cool. Now, again, this is a very simple function. So this is one that I wrote for this particular example. And this is a SurrealQL function, which is very similar to SQL functions. However, what this thing is doing here, and I'll walk through the steps, is it's going to take an input of, in this case, a question, what was the main character's first name or whatever, and it will take that text and it will turn it into embeddings. And the way I'm doing embeddings in this particular example, I'm using a Word. I believe I used Word to Vec, or it could have been fast text. Regardless, the trick here is it will retrieve from that sentence, it'll split it into tokens, and then each of those will find each of the words, and then calculate using linear algebra the average. And then from that, it will be able to now find other elements within this graph. So the first step in that query after we get our vector is to do a semantic search. In this case, this is using a cosine similarity search, where you can see that 5. And by the way, those triangles are just how the UX spits it out. It's really just a less than or greater sign and a pipe. And it's going to return the 5 closest matches to my question, basically. And then the next really interesting thing is, if anyone can see that arrow, that's how we traverse our graph. And so it's going to find people who are related, and the people that, and how the things that they are related to, because it could be a person or a place, and return their strength and description. So conceptually, this one function will return the descriptions of people and what they're related to. And I see we have a graph coming. When is it beneficial to use knowledge graphs in RAG-based applications, a trade-off between complexity and usability? Shalina, that's an excellent question. I think there's probably no use case that wouldn't be useful to throw in a graph at. I think the challenge is going to be, can you generate one? So I'll save that. That's a TLDR to get to the end. But yeah, any follow-up questions on that would be also useful. I'd love to hear anyone's use cases as well, and we can follow up online. Okay, so now based on that little function, here's an example. I spit that in, and this is what I get back out. The response is truncated here, but you get the point. Getting a mix of people and persons and places. You see the description of the actual the person that we're matching on semantically. So obviously it's matching on Alex Mercer and things like that. And then this is the graph that's returning. And I should say, if you notice, this is just one way to do it. We have embeddings at the actual graph as well. So I could have also made the logic for retrieving this graph is first grab the people and places. And in this case, I should say I'm being very simple because it's a very short, small corpus. I can fit the whole corpus into the context window. So I'm cheating. If you imagine if there was chunked corpus, I could say like, hey, just bring the chunks of the corpus and then bring individually a graph related to each corpus entity, chunk entity. Or I could have said, hey, run a graph knowledge query independently, and I could have done it. And you'll get different results depending upon how you're building your application, to be fair. So there's no one way to do that. I think that's also back to Shalini's question. And this is what we end up with. We're going to spit this little knowledge graph, copied and paste, basically, inside there. And let's take a look. What happens? So, very simple question, but if you look at this question, it's one that usually an LLM is going to struggle with, because it's going to ask, it's asking interpretations in what hold dearest. That's a really tricky question. It's asking about relationships, right? So if you see, it doesn't really answer the question very well. And suffice to say, if I throw the graph in there, well, it gets a little bit better. In fact, it throws in the notion of the people and the places, and it explicitly talks about the people and places independently, and it talks about referencing the knowledge graph. And I will say, if you take a look at the repo that I posted, I even do this with some reasoning. I just use DeepSeek, for instance, for just to play around with it. And you can see in the reasoning the difference between what's going on. The LLMs will actually acknowledge that the graph when to come into play. And if you play with prompt engineering, you can even imagine how you're going to say explicitly use a graph or use it as a guiding light. However you see fit, you can really get really dramatically different results. And this is just a little bit subtle, very small corpus. So this is what I've discovered in my time just playing around with this stuff and getting good with it. Obviously, you're going to have a much more efficient context window. You can put a lot more information to the LLM by putting a graph in front of it. It's kind of like another way to hack, just getting more information to the LLM. It also will focus the LLM, because it's going to have access to inference and relationships that it would have to pierce out, and it's going to be consistent with its nuanced response. So effectively, you're going to be able to reduce your hallucination quite effectively, because if you're putting in a knowledge graph that is a very solid understanding of the universe, it's going to guide that LLM appropriately. And in this case, it's also kind of interesting because it allows it to also get this motivation, right? So if you imagine the way that you could do this is just do multiple passes through this thing, and this is one way to look at it. Well, you kind of have that short circuit, so that you're not having to say like, hey, let me understand all the motivations of the characters, and based upon that, let's move forward. You're going to get all this kind of in one big go. And lastly, since you're providing the graph independently, it will allow it to be more objective in its reasoning. So what if you don't have a graph? This is, I think, probably one of the biggest challenges for a lot of people. Bear with me. How do you get one? I will say it's not always easy. So I think traditionally a lot of the knowledge graph providers of the world would assume that there's a whole cadre of people out there who are going to meticulously put all of their information in nice forms and connect everything, and nothing ever changes. And when it does, it's okay. It can go through a process. We know life isn't like that. We also know that, to be fair, the LLMs of the world have kind of, spoiled people that, unstructured data. So what? I'll just throw an LLM at it. And that is one strategy. In fact, this is the first one I'm going to talk about. So in this context, this is exactly what I did. This was a very small corpus. Again, maybe it's like a novella that was like, 50 pages or something like that. It was very easy. You just say, hey, extract all the information from this and put it into this format of, in this case, I had it spit it out as semantically correct SurrealQL's code. But, it'd be like, hey, give me a JSON representation of all the people and places, how they're related, consider how confident you are as the strength of their bond, or all the different ways that you would want an LLM to do it. Excuse me. And it'll come out in a great format. It'll work. But it can be noisy, right? It might, make things up, hallucinate, like overly confident in certain ways. Also, even with a reasoning model, it's still black box. You can read the reasoning model, and you can imagine if you're automating this thing, you're not going to be, you need an interpreter of the reasoning model's explanation in order to get to, was this accurate? which again, this is like going 2 levels deep. It's going to get very challenging. And I think the biggest problem is with a very small corpus, sure, you can do that, or if you're not doing it all the time. But yeah, running this through an LLM is very resource intensive. So if you imagine it's going to take 30 seconds to return a response, even using something like one of the Flash or one of the speedier ones, if you have $1 million, pages of corpus to go through, you're going to be there all day. So has its uses. It's great, probably great for like one-offs and things that are pretty static, and you can work with it and go like, yeah, I'm going to build my knowledge graph and use it for a while. Great. And it's a good place if you have just lots of unstructured data you don't really have a good notion of, right? However, another play is to use NLP library. So I do an example of using Spacey. Now, this is interesting because now, again, it's using a little bit more of the machine learning approach, which means you can actually say in a generic way, like extract all the person entities, all the company entities, and you can really go after it in a much more controlled way. It's also very helpful if you do have some semi-structured notion of like, maybe where the headers of the information, so that maybe a company name's in there and you can kind of seed it. You'd also obviously have to have a good understanding of what is in the types of object data that you're putting into it. I think it's very effective. I've used it. It's great for fuzzy logic matching, and it's also really cool because you can, without going full LLM, extract things like verbs for your edges. So really, really good, really effective, cheaper in terms of like manpower and CPU power. Actually, GPU power is better than full-on LLMs. But yeah, it has its caveats. You really have to, do a lot more programming in order to make this work well. I mean, LLM, you just throw it at it, right? And it does struggle with complexity. When I'm using these, I find that sometimes it'll mislabel people as companies and companies as people. But these are still things that can be worked around. At the end of the day, it's a very powerful technique as well. And this is another way to do it. In fact, this is probably the cheapest and easiest way to think about doing this. So if you see there's a little SQL statement here, and basically you can use full text search, right? So this is very useful when you have like a master list of information, right? You do have your employee roster, you do have your lists of companies, you have your list of main characters, or you have your product lists, and now you can use full text search, right? And this is great because you'll just be able to pull things out. And you can also use vector search, and then you can do some form of hybrid and scoring and things like that. This is very powerful when you already have some single source of truth, and now you want to build your corpuses and you want to tag it, and then you want to build a nice model around that in terms of a knowledge graph model. I've gotten a lot of bang for the buck out of this technique as well. And I'm just checking time here, so we'll leave about 5 minutes for questions, unless there's no more, and I'll keep going. But this is a little matrix I put together to kind of like a decision matrix of when you think it's most appropriate. Our colors are pink, so this is what I would suggest. So obviously most comprehensive for LLM graph. So if you had fully unstructured corpus, you might just want to start there and see what you can do. Maybe make it part of building down that structure. So you just want to pull stuff out at first and make that your definitive list. But again, it's slow and expensive, right? So NLP, again, if it's fully unstructured, it's going to be a challenge. You're going to have to do something to get it to semi-structured, and you're going to have to do a lot of work there. However, if it's, if you got a decent understanding of your data, it's going to be very effective. That being said, if you do have rows and columns to a certain degree, and you're just trying to do fuzzy logic matching and things like that, you're going to be very surprised at how effective just using your database capabilities of full text and vector search inside the database is really effective. So that's where I would put the decision matrix of where to consider playing around, which is back to show me the point. Okay, so multi-model. Why are we here? Why did I mention multi-model to begin with? In this case, specifically, it's all about graph and vector. And I don't know, I'm dating myself here, but this is a Reese's commercial where it's a girl walking with a thing of peanut butter and a guy walking with a candy bar, and they run into each other, and it's, anyway, the point is that when you have graph vectors, graph databases and vector databases in isolation, they do different things, and they're built for use cases that aren't very synergistic, right? When you put them together, as I've shown you with this GraphRag example, you're going to get really, really interesting synergistic effects of what you can do. So going back to that, do you search the graph or do you search the corpuses? And do you go first to the other? Do you connect the chunks of information with graphs to other chunks of information? All this becomes really, really powerful when you combine it and build new ways to look at your context windows. And this is a long video. Be mindful of time. I would normally let you watch that. However, we don't have that much time. So this is why SurrealDB wasn't actually originally architected, but this is what's become emergent, what we see more in time out. The multi-model architecture gets people interested. The reason why it's performant, though, why we get away with it, is because it's entirely built in Rust. So we started rebuilding the whole thing for performance, so we can do multiple different ways of querying your data on the same data plane. Data nerds out there, ACID compliant, check the box, scalable, portable. You can deploy it literally in JavaScript, or you can deploy it in a massive distributed manner. And we're really built for AI and ML workloads at the end of the day. It's becoming more and more apparent that having multiple tools to power your ML workflows is more and more of a challenge, because now you have to handle multiple different databases, multiple different versions, multiple different SDKs, all these things. It becomes so much simpler when you can actually execute these in the same place. This is just a brief sample of all the types of things you can query and the ways that you can query in our database. And just briefly on the architecture, what becomes really, really cool is if you can separate your compute from your storage. That allows you to do amazing things like have data scientists spin up massive clusters. At the same time, you're going to have applications that are just loading data, or little, your embedded apps for your end customer and things like that, all on a single data platform. So you can start thinking about the art of the possible of having your data scientists have real-time data as it's coming, not after going through complicated ETLs and maybe losing information along the way. And conversely, you could have models that are up to the minute being deployed as SQL functions inside your database. All this becomes super relevant in this new modern architecture. And I believe I have about 2 minutes, so I just wanted to show you a little bit about how these SQL statements work in that example. So this is our language. This is how you would create nodes. So you create an entity, and you're setting its description. And then you can use a relate statement that would relate one entity to the other. And you can put different semantic, you can put different metadata along there. And in this case, all of those vectors were actually calculated on the fly on ingest. So that was just done with a default calculation. So again, this was an example of how we can do those get embeddings. And I wrote a little function here just to show you how you can do this with a word-based embedding model. And in that little def sentence to vec, it's basically grabbing the tokens. And in that, it's going to just be calculating the mean and the zeros. And then you can actually reflect that directly in SQL in our flavor. So, and on that note, I came to that. And I didn't see any questions, but we got 1 more minute. Any last minute questions? Happy to follow up. If not, please connect with me.